Hello people and welcome back to Maybe Ismail, and today is a different day because we are recording on a lavalier mic. The audio probably might be a little bit different because this mic is a wired mic and this thing does not have an inbuilt noise cancellation feature. So yeah, we'll get to know after the episode is out. So today we'll be doing ratio and proportion. Now this thing will have two episodes. In the first one, that is this one, we will be doing all the concepts, the basic concepts that are needed, and we'll be doing a few basic questions. And in the second one, we'll be doing a few more questions which are slightly on a higher level. Okay, so let us directly dive into the thing. Okay, so I am 100% sure that everybody knows what ratios are. Okay, so ratio is basically when you compare something with some other thing. So like in trigonometry, we compare the ratio of two sides. Okay, so we just say that sine theta is the ratio of opposite and hypotenuse. So it is ratio of two sides because you are comparing the two sides. Okay, one other example could be the ratio of my age to your age. So let's say my age is 200 years and your age is 50 years. So it could be 200 is to 50 or 4 is to 1 when simplified. Okay, so I basically represent ratios as A is to B or maybe X is to Y. Now for simplification purposes, we also write the ratio in terms of fractions. So A upon B, and this could be X upon Y. This is just for simplification, it is not the same thing. Okay, now just a side note, I would say over here that this thing over here, the two dots over here which I put in between the two things, that dot is known as colon. I know everybody knows that. What everybody does not know is what is this small thing, that small line between the numerator and the denominator. So that line is known as a vinculum. It is V-I-N-C-U-L-U-M, vinculum. Okay, that's the line between the numerator and the denominator. Does not have anything to do with the unit that we are studying. It's just a side note. Okay, let us move ahead to proportion. Now if you know what ratios are, you will surely know what proportions are. Now my phone is kept over here and I was just thinking it is 12 is to 32. So that thing is also basically a ratio. So 12 and 32, there is like a colon in between them. Okay, and when I simplify that, it could just get reduced. Okay, so what I was saying is let us do proportions. Now if you all know what ratios are, and if I say that there are two ratios which are equal to each other, so if two ratios are equal to each other, they are proportionate to each other. So I can say that my ratios A is to B if this thing is equal to C is to D, then they are proportional if they are equal. But when I write it in terms of ratios, I don't put an equal to sign in between them. I just put two colons and it is read as A is to B as C is to D. Now if I write it in terms of fractions, I would obviously put up an equal to sign. So A upon B is equal to C upon D. Okay. Now if I look over here very closely, A is at the leftmost extreme and D is at the rightmost extreme. So if it is at the extremes, we call them the extremes. So A and D are basically the extremes and B and C are the middle things, then you call it the means. Okay, so B and C are basically the means and A and D are the extremes. Okay, so A and D are extremes, B and C, since they are in the middle, you call it as the means. Okay, what else? Can I send the D to the other side and B to the other side? So it becomes A times D is equal to C times B. Okay, that is an equation which I got over here. Now you see A and D, they are getting multiplied, B and C, they are also getting multiplied, and there is an equal to sign in between them. So can I just make a statement that the product of extremes is equal to the product of means? A and D, extremes, so the product of extremes. C and B, the means, so the product of means. The product of extremes is equal to the product of means. You can use this to solve a few basic questions here and there. Okay, one more thing, that the D thing over here, the last one, is known as the fourth proportion. It is the fourth proportion over here. Okay, now let us come to continued proportion. Now what are continued proportion? I will first write it in terms of fractions. So let's say I have A upon B is equal to B upon C is equal to C upon D is equal to D upon E, and it keeps on going. Okay, in this one, if you see very carefully, the previous denominator is exactly available in the next numerator. So B over here and B over here, C over here and C over here, D over here and D over here. So every denominator is getting used up into the next numerator. And if I consider just the first two things, like I know all of these are equal, we'll study just the first two things. Okay, in this thing I can see A is the leftmost extreme, C is the rightmost extreme, and B, which is the middle one. Now B is the same thing for the denominator and the numerator. Okay, so I call my B to be the mean proportion. It is the mean proportion, and the C is the third proportion over here. C is the third proportion. Okay, you can also call A as the first proportion, but it's okay, I'm just not writing it over here. So B is the mean proportion, C is the third proportion. Okay, and again A into C is equal to B square. That could be a thing. So A into C is equal to B square, or I can say that B is equal to square root of A into C. Okay, now this is something that is to be remembered. You will surely see this B is equal to square root of A into C somewhere else in life, and just to give you a hint, it is something to do with geometric progression or its geometric mean. Okay, well, let us move ahead to something really important, which is properties of proportion. Okay, so before starting properties of proportion, I am just presuming something, that I have a proportion which says A upon B is equal to C upon D. So this thing holds true, like A upon B is equal to C upon D. This is a condition. Now with this condition, I'll have a few properties. Let's see what those properties are. The first thing is invertendo. The name suggests it, just take it and flip it around. So if A upon B is equal to C upon D, then obviously B upon A will be equal to D upon C. Okay, very easy. Just pick up any random numbers for A, B, C and D, which should all obviously be equal to each other, the two ratios, and then you just flip it and check, it would obviously be the same exact thing. Okay, now the next one is alternando. Alternando basically says that swap the positions of B and C, like that C can come to the denominator and that B can go to the numerator. Okay, so alternando is A upon C is equal to B upon D. Now these are very obvious, like normal. Even if you don't know the names, you can obviously do it, and you already have done it many times. The important thing is componendo. Now what is componendo? Componendo says just add the numerator and denominator. So A plus B upon B, that will be equal to C plus D upon D. Okay, this thing is true. Like if A upon B is equal to C upon D, then A plus B upon B should be equal to C plus D upon D. That is known as componendo. The next thing is dividendo. Same exact thing, just a minus sign in between them. So A minus B upon B would be equal to C minus D upon D. Okay, so that is componendo and dividendo. Now the last one is componendo dividendo, which is basically a combination of these two. So what I do is I just divide these two equations which I have over here. So let's say I put up a division sign over here. When I divide these two, I just get A plus B upon A minus B is equal to C plus D upon C minus D. So if the first ratio, which is A upon B, is equal to C upon D, that ratio is true, that proportion is true, then all of these things are also true. Now to remember the componendo thing, it is actually numerator plus denominator upon denominator and equal to, again, numerator plus denominator upon denominator. Dividendo is numerator minus denominator upon the denominator equal to the same thing. And componendo dividendo is just the sum of, like, just the combination of both these things. So numerator plus denominator upon numerator minus the denominator. Okay, so these are the things that you should know before getting into the chapters, like solving the questions of this chapter. Okay, let us start solving the questions. Okay, so here is the first question. The first question says find the fourth proportional to 3.5, 4.5 and 10.5. So it's asking me what the fourth proportional is, which means A is given, B is given, C is given. I need to find what D is. Okay, so let us just say that A is this thing, B is this thing and C is this thing, and there is something over here D which I just need to figure out, and I don't know that thing. Okay, now can I just say that A upon B would be equal to C upon D? Let us just plug in the values. So this would be 3.5 upon 4.5 is equal to 10.5 upon something. Let us just call it X, or we can also call it D. Let's just call it D. Okay, now I see that everybody has one decimal place. I'd be really happy if I just multiply the entire thing by 10. Okay, so just multiply everything by 10 so that the decimals go away. So this would become 35 upon 45 is equal to 105 upon, don't forget to multiply the D with 10 also, so it becomes 10D. Let us simplify all of these. This would go in 5, so 5 7s are 35, 5 9s are 45, and this would go in 5 times 21 and 5 times 2. Now I can just send the 2 and 21, or maybe the D to the other side. So this becomes 2D is equal to 21 times 9 upon 7, and I can probably keep the 2 also over here, so 2 remains here. Okay, 7 times 1, 7 times 3 is 21, 3 9s are 27, so the value of D would be 27 upon 2, and that is my fourth proportional over here. Okay, let us look at the next question that we have. Again the same thing, A is given to me, this is A, this thing is B, this thing is C, and there is some D over here which I don't know and I need to figure it out. Okay, again the same thing, A upon B would be equal to C upon D. Okay, what's the value of A? It is 5x. What's the value of B? It is 15x square. What is C? It is 4xy, and D is unknown, so I'll just write D over here. Let us try to simplify all of this thing. 5 times 1 is 5, 5 times 3 is 15, one of the x's can just go away. Okay, I have a 3x in the denominator here, it goes to the other side, the D comes to this side. Okay, so D is equal to 4xy times 3x. So D would finally be equal to 4 times 3 is 12 and x square y. That is basically your fourth proportional. Very easy. Let us move ahead to the next question. This thing says find the third proportional to. Now whenever they talk about the fourth proportion, we know that it is A, B, C and D. And if they talk about the third proportion, we should know that it is A, B, again B and C. So it is basically a continued proportion thing. Okay, so here this thing is A, the first thing is A, the second thing is given to me as B, and I don't know what C is, so I need to figure out that C over there. Okay, so here I would say A upon B would be equal to B upon C. Let us just plug in the values. Firstly, I do not like that 4 1 upon 3. I need to convert that mixed fraction to a normal improper fraction. 3 4s are 12 plus 1 is 13, so it is actually 13 upon 3 upon B. B is just 2 is equal to 2 upon C. Okay, so now these things can just go here and there, so it becomes 13 over 3C is equal to 2 times 2 is 4. Now just send the 3 to the other side and 13 to the other side, so it becomes 3 times 4 is 12 over 13. That is basically my third proportion in this one. Okay, let us move ahead to the next one. Over here again, the first thing is given, which is A, the second thing is given, which is B, and the third thing, which has to be something, is not given to me and I need to figure it out. I'll say the same thing, that A upon B should be equal to B upon C. Okay, just before moving ahead, I'll just shift things so that there is less complication. So can I just say that B square is equal to AC? Now this is something which we already know. Okay, B square means A square minus B square, all of that getting squared, is equal to A. Now what is A? A is A minus B times C. C is just something which we don't know. Okay, now this A square minus B square is difference of squares. Okay, so it can be written as A plus B into A minus B. So it is A plus B into A minus B, and then since I have a square on top, this square, so that square goes to both the brackets. So I put up a square over here, I put up a square over here, is equal to A minus B times C. I can get rid of one of the A minus B from both the sides. So A minus B goes away, A minus B goes away, and I'm just left with C is equal to A plus B whole squared times A minus B. Now this should be your answer. If it turns up in an MCQ, just compare it and just write whatever answer is there. Here you can simplify the brackets, open up the brackets and do whatever things you feel like, but I feel this should be enough as an answer. Okay, let us move ahead. This one says find the mean proportional between. Now it has given us two things. So if two things are given and we need the mean proportion, which means it is talking about A, B and C, it is a continued proportion. Okay, so the first thing that is given to us is A, the second thing that is given to us is C, and I need to figure out what B is. Okay, I won't write A upon B is equal to B upon C. I'll just use my logic which I have developed already, that B square is equal to AC. Okay, so let B square is equal to AC. Okay, so B square would be equal to A, which is 5 minus 2 root 2 times C, which is 10 plus 4 root 2. Opening up the bracket, 5 goes to both of them, 5 times 10 is 50 plus 5 4s are 20 root 2. Then the negative 2 root 2 goes to the other, like the bracket. So 2 times 10 is 20, so negative 20 root 2, and 2 times 4 is 8, and it becomes root 2 times root 2 is 2, 8 times 2 is 16, so it is negative 16. The positive 20 root 2 and negative 20 root 2 just goes away, and I'm left with 50 minus 16, which is just 34. Now b square is actually 34 over here. I did not need b square, I need the value of b. So if b square is 34, b would be square root of 34, and I can keep that answer as it is. Or if you have the log tables, you can obviously use them and find the value of that thing. Okay, let us move ahead to the next one. Okay, so this one also is the same kind of question. I have been given a, so the first thing is a, the last thing is c, and I need to find the mean proportion, which is b. I don't know what b is. Same logic, b square should be equal to ac. Okay, b square remains as it is equal to a, which is a minus b, times c, which is a cube minus a square b. Now I just feel like I can factor out an a square from the second bracket. So the first bracket a minus b remains as it is. From the second bracket, if I factor out a square, I'll be left with a minus b. Now I can see there is a minus b, there is another a minus b, these two combine and become a minus b all squared. So this is a minus b all squared times a square, and this thing is equal to b square. Now I don't need b square, I need the value of b. So b would be just square root of all of these things. So all the squares just vanish away. So it would be a times a minus b. Now obviously I can write a plus or a minus over here. It would like be the same thing. So I'll write plus and minus of all of these things. I can send the a inside, but this should also be correct as your answer. Okay, now let us move ahead to the next one. This thing says if x is the mean proportion between this and this, find the value of x. Very easy. X is the mean proportion between this, so this is a, and this, so this is c. So mean proportion, which means x is actually b. So can I say that b square is equal to ac? Okay, b is what? B is x. So I just write x square is equal to a, which is x plus 2, times c, which is x plus 9, opening up the brackets. So x square plus 9x plus 2x plus 18. So that is equal to x square plus 11x plus 18, and I have an x square on the left side also. Let us just cancel out both the x squares. Now the 18 goes to the other side, so it becomes 11x is equal to negative 18, and finally x would be negative 18 over 11, and that is my final answer. Simple, very easy. Okay, let us move ahead to the next one. This one says if m square, 9 and 25 are continued proportion, find the value of m. So if these things are in continued proportion, I can just say that a upon b is equal to b upon c, or I can use the logic, which is b square is equal to ac. Now m square, 9 and 25. M square is a, 9 is b, and 25 is c. Okay, so instead of b, I will write 9 square is equal to, instead of a, I'll write m square, instead of c, I will write 25. Okay, now I need to find the value of m. Can I just send the 25 to the other side and write it as 9 square upon 5 square is equal to m square, because 25 is actually 5 square. If m square is 9 square upon 5 square, I can just square root on both the sides. So m would be equal to 9 over 5. The squares just go away, and I'll have to obviously write a plus or a minus. So 9 upon 5 is a good answer, or I can just say it is 1.8. That is also a good thing to do. How did I just divide it very quickly? It is basically a trick that if you have to multiply anything by 5, you just half the number and put up an extra 0. So let's say I need to do 8 times 5. So 8 times 5, half the 8, which is 4, and then put up an extra 0. 16 times 5, half the 16, which is 8, put up an extra 0, so 80. Similarly, for division, you just reverse the process. You double the thing and give a decimal place. So double of 9 is 18, and if I give it a decimal place, it would be 1.8. So it is plus or minus 1.8. Okay, or I can just keep it as a fraction. That's not really a problem. Okay, the next question says if y is the mean proportional between x and z. So y is the mean proportion between x and z. Fair enough. Show that xy plus yz is the mean proportion between this and that. Okay, now the first thing that is given to me is regarding x, y and z. So y is between x and z. So can I just say that x upon y is equal to y upon z? Yeah, that looks fair, which means y square is equal to xz. Okay, so y square is equal to xz. Okay, let us move ahead to whatever it says. Now it says show that this thing, the xy plus yz, is the mean proportional between these two things, which means that this could be my a, this could be my c, and I need to prove that xy plus yz is actually b. Okay, so I'll use my logic, which says b square is equal to ac. Now what is a over here in this question? A is given to me as x square plus y square, so I write it there, times what is C in this question? It is y square plus z square. Okay, now all of this should like simplify. The B value should be equal to xy plus yz. Let's see how it becomes. Okay, what do? I just use the given data in the question. Now the data is saying that y square is equal to xz, this thing. I'll just substitute the value of y square over here and over here. Okay, so this thing becomes x square plus, instead of y square I'll write xz, and then in the other bracket instead of y square I'll write xz plus the z square. Okay, can I just factor out an x from the first bracket? Okay, so it becomes x plus z. I can factor out a z from the second bracket, so it again becomes x plus z in the bracket. Now this thing can be written as x and this z together, so xz times, there is a bracket which is x plus z, there is another bracket which is x plus z, so x plus z times x plus z is x plus z, all of that square. Now this is the value of actually b square. Now xz is actually y square if you look over here, so xz is y square, so I'll just write this thing to be equal to y square times x plus z the whole square. This is equal to b square. I don't need b square, I just need b. So if I need b, I can just square root on both the sides. So finally b would be equal to y times x plus z. I open up the bracket, y goes inside, so this becomes y times x is xy and y times z is yz, and that is exactly what is asked in the question. The question says that I have to show that xy plus yz is the mean proportion. Mean proportion was b and it turned out to be xy plus yz, and I'm really happy about that. Okay, so you should understand what is given in the question. You need to use that given data and you need to use it somewhere in the question that helps you simplify the equation that is given to you or which you derive. Okay, fine. Next question, this says find the third proportional to this thing. So if it says find the third proportional, which means A and B are given to us and we need to find a C over here. Okay, same logic, that B square is equal to AC. So B square is equal to AC. I'm really happy because B square is supposed to be done and I have a B which is already a root. So that's a very good thing for me. Okay, so root of x square plus y square, all of that squared is equal to A. Now what is A? It is x upon y plus y upon x. This is A times the C which I need to find. Now I know a lot of you would just be scared of this question because there is a square root, there are fractions and nothing looks really liable. So you just like leave the question. Okay, you don't have to, because like in a GFE this question would be very easy. I can cancel out the square and the square root over here. I'll only be left with x square plus y square is equal to, in this bracket on the right hand side, can I just cross multiply the fraction and this becomes x times x, which is x square, plus y times y, which is y squared, upon, when I just multiply it becomes xy and there is a c there. Okay, now if I see the numerator on the left side and the numerator on the right side are both x square plus y square, just cancel out x square plus y square from both the sides and send this xy from the denominator to the numerator, and finally c would be equal to xy, and that is your answer. That's how easy this thing is. Okay, fine, let us move ahead to the next question. This is the last question of this episode. Okay, it's a very interesting question. Now this thing says if p plus r is equal to mq and 1 upon q plus 1 upon s is equal to m upon r, then I have to show that I have to prove that in fact that p times p is to q is equal to r is to s. Okay, now the given information, like the equations that are given are more, and what I need to prove is like very less. Okay, firstly I don't like this ratio notation, so I'll just write it in terms of fractions so that I can solve it, or I can at least see what is required. Okay, so this thing can be written as p upon q is equal to r upon s. Now if you look very closely in my question, this thing says p plus r is equal to mq and this thing says 1 upon q plus 1 upon s is equal to m upon r. But in my answer I do not need an m, which means I need to get rid of the m from these equations. Once I get rid of the m, my life would be really easy. Let's see what can be done over here. Okay, so let us take the thing, and can I just say that p plus r is equal to mq. I send the q to the denominator. Okay, so it becomes p plus r upon q is equal to m. Okay, now I can obviously split the denominator with both of them, so this becomes p upon q plus r upon q is equal to m. That is the first data that was given to me, which I already used. Let us move ahead to the next information which is given to us, which is 1 upon q plus 1 upon s is equal to m upon r. Okay, now if I send this r to the other side, it gets multiplied with both of the things. Okay, so it would be r upon q plus r upon s is equal to m. Now if you see, both the right hand sides like of both the equations are equal, they are m. So if I say that the right hand sides are equal, then obviously the left hand sides should also be equal. Okay, which means that p upon q, I just feel like I should not like distribute this thing. I would just keep it like this. Okay, that would really probably help me a little bit. Okay, so I can just say that p plus r upon q is equal to, even over here I can just factor out an r, okay, and write it as 1 upon q plus 1 upon s. Okay, now in the on the right hand side I can simplify that thing, and I'll write r times s plus q upon qs, and this thing is p plus r upon q. Okay, now I can get rid of this q and this q from both the sides, and I can send this s to the other side and it gets multiplied. So it is s times p plus r is equal to r times s plus q. I'll open up these brackets, so it goes inside and becomes sp plus sr is equal to, r goes to the both the terms inside the bracket, so it becomes rs plus rq. Now I can see an rs and sr basically on both the sides. We can cancel them, and I'm left with sp is equal to rq. Q can go to the denominator, s can go to the other denominator, so p upon q is equal to r upon s, and I can finally say that p is to q is equal to r is to s, and that is how I do it. Now if you observed over here, I actually split up the denominator, but then I realized that okay, I don't need to split up the denominator. And this is one thing which I advise all my students, that if you have already done a step, don't be hesitant to go back to a step. Like if you feel that I have done this step, but this step is not important for me, the previous step is important, and that could probably simplify the things that I'm going to work out now. So just ignore that step, cancel it out, and use the previous step, or just ignore all the calculations that you have done and start from scratch. Okay, like I did it over here. I just felt like that thing would have probably made the question like maybe 2 steps longer, so I just erased those steps. Okay, and that is it for this episode. I'll see you in the next episode with a lot more questions, and till then I would also like to say that whatever videos I'm posting, these things that you see over here on the screen, you are not supposed to write when I'm explaining. That is what I advise in my class also. Just listen to what I'm speaking. All of these notes, the written thing which I'm writing, exactly these things are in the description of this video. It is uploaded in a PDF form. Also, all these questions that I've written here, all these questions are put up in one single worksheet, and they are put up in a PDF form in the description. So when you are watching the video, just watch the video, focus on the video, and do not write anything simultaneously, because you'll end up pausing it multiple times. You'll be playing it, pausing it, playing it, pausing it. Just don't do that. Okay, and that is it. I'll see you in the next one. Thank you so much.